So today we're going to graph lines in standard form. And if you remember, standard form is y equals mx plus b. So the equation we want to graph today, or the line we want to graph today, we're going to try this example. It's going to say 7x plus 2y equals negative 10. Okay, now this equation is not set up in standard form. If you notice, the x is first, but we need the y first. So what we need to do is we need to go back to our basic algebra and we need to balance this equation. So in order to get y by itself, we need to remove all the terms that are on the same side of y. So what we're going to do is we're going to subtract 7x, and in algebra, we have to do it from both sides. And if we subtract 7x, that's a terrible line. If we subtract these 7x from both sides, these will cross out. And on this left side of the equation, you are left with 2y. And on the right side, you're left with negative 7x minus 10. Now, I put the 7x or the negative 7x first because we need to keep this aligned with our mx plus b. Even though we subtracted it, it would read negative 10 minus 7x. I just like to make life easy. Now, we do have y by itself. Aside from, we have to get this 2 away from it. This is multiplication, so in order to undo multiplication, we need to divide. And we always divide by the coefficient that is in front of the variable because it will leave just that variable. So we divide by 2, which means on this side, we have to divide each term by 2, the negative 10 and the negative 7x. Again, if you notice, these 2's cancel out. Down here, you're left with y equals. We're getting closer to our equation here. So we're left with y equals negative 7 over 2 x. And a negative 10 divided by a positive 2 gives us a negative 5. So here's our equation in y equals mx plus b form, or standard form. Now we can come over and we can make a t-chart on some x values to find some values for y so that we can plot this graph. Okay, so I like to make life easy, as I said, so we need to think of x values that are going to help us get rid of this denominator, to eliminate this denominator. So why not pick a negative 2? Let's try 2, and let's try 4, because these are all multiples of 2 or have something in common with 2. So if we plug this negative 2 in for x, we're going to start and we're going to say y equals negative 7 over 2. And we have to multiply this by a negative 2. And since negative 2 is a whole number, it goes over 1. If you notice, due to cross-reducing here, you can reduce the 2's by 2. So if 2 divided by 2 yields 1, and negative 2 divided by 2 yields a negative 1. Notice the negative stays. So for our numerator, we now have negative 7 times negative 1, which gives us positive 7. And here's the rest of our equation, minus 5. So 7 minus 5 gives us 2. So if x is negative 2, y is 2. Now let's plug in 2. Let's see what 2 gives us. Y equals negative 7 over 2 times 2 over 1. And we have to bring this minus 5 over from our original equation. If you notice, the 2's are both positive again, so they're just going to cancel out. You're left with negative 7. So now we have a negative 7 minus 5. Well, we have two negatives here. So negative 7. And technically, we are going to be adding a negative 5, which is going to give us a negative 12. So if we input 2 for x, we get negative 12 for y. Now I'm running out of room over here, so we're going to come up here. And now we have to plug in 4. So we have y equals negative 7 over 2 times 4 over 1, and we have to bring our minus 5. 2 and 4, 2 can go into both 2 and 4. So 2 divided by 2 gives us 1, and 4 divided by 2 gives us 2. We have a negative 7 times a positive 2. Negative times positive gives us a negative 14 minus 5. So again, here it's like adding a negative. And we are left with y equals negative 19. I'll upload another video so I could show you how to graph this. But here are your coordinates. Your ordered pairs are negative 2, 2, 2, negative 12, and 4, negative 19. I'll see you in the next video.